Presenting forces and force diagrams. Types of forces. The normal force is a force that is perpendicular between two objects in contact. There are two types of friction force, static and kinetic. Static friction is a force that opposes the object's direction of motion. If static friction is absent, then the object would move. The second type of friction force is called kinetic friction. Kinetic friction also opposes the object's direction of motion. When kinetic friction acts on an object, the object will continue to move, although an opposing force is acting on it. The gravitational force is the force of the entire Earth pulling an object down. A tension force is a force in which a string, rope, chain, or any other object that can create tension pulls the object in the direction of the tension. To show examples of all of these forces, in this diagram, what forces are acting on the ball as it sits motionless on a table? A normal force is acting on the ball, coming from the table. As you can see, the table is perpendicular to the ball, which is the definition of a normal force. The second force that is acting on the ball is the gravitational force, because the entire Earth is pulling the ball down. Now, the ball on top of the table is rolling across the table. The table is no longer frictionless. So, what forces act on the ball as it rolls across the table now that the tabletop is no longer frictionless? One would be the normal force from the table onto the ball because the table is perpendicular. The gravitational force from the entire Earth, and also the friction force, specifically kinetic friction because the ball is in motion. In addition to the normal force and the gravitational force acting on the ball, there's now a rope that is pulling the ball across the frictionless table. So now, in addition to the normal force and the gravitational force, there's a tension force created by the rope on the ball. The ball has now rolled off of the table. What forces are acting on the ball after it rolls off of the table, but before it hits the ground? The ball is in mid-air, so that means that the entire Earth is the only force that is acting on the ball. The entire Earth exerts the gravitational force, which is pulling the ball down to the ground. There are multiple ways to show the forces in a situation. One way is the system schema, and another way is by using a force diagram. In a system schema, the system is drawn with a box around it to show that it is the system that is being focused on. In a force diagram, the object of focus is shown by the dots. The arrows show the forces that act on. There are multiple ways to demonstrate forces between objects. Two ways include system schemas or a force diagram. The system in the schema, which is the object of focus, becomes the dot of a force diagram. Another difference between system schemas and force diagrams is that the force diagrams focus on the forces acting on only one object and the direction of those forces, whereas system schemas show the forces between multiple objects in a situation and do not show direction of force. Force diagrams not only show what forces act on a specific object, but they also show what dimension each force occurs in. These dimensions are the x and y dimensions. Each dimension has a positive and negative aspect. Equality marks are used on force diagrams to indicate if the forces are equal or unequal. If forces are equal, then they would have the same number of equality marks. If the forces are unequal, then the number of equality marks on each vector would differ. In this example, the forces in the y dimension are equal because they each have one equality mark, whereas the forces in the x dimension are unequal because they have different amounts of equality marks. When forces are equal in a dimension, the object is not accelerating and has a constant velocity. This velocity could be static or dynamic, meaning that its velocity could be 0 or any other velocity as long as it is constant, as seen in the y dimension in this example. When forces are unequal in a dimension, the object is accelerating in the direction with greater force. This also means that velocity is not constant. In addition to equality marks, the vector with greater forces should be drawn longer than the other vector, as seen in this example. The object is accelerating positively in the x dimension. In this example, a ball on a tabletop with friction was pushed by a hand and is now rolling across the table. What are the forces acting on the ball? A normal force by the table and a previous normal force from the hand that pushed the ball. Kinetic friction is acting on the ball by the table. The friction is kinetic because the ball is still in motion. Finally, gravitational force acts on the ball from the entire Earth. Looking at the force diagram, we see that the forces in the y dimension are equal, meaning that the ball does not accelerate up or down. But the forces in the x dimension are unequal. Although the ball continues to roll to the right, the ball is decelerating or accelerating in the negative x dimension because of the kinetic friction. The ball is still rolling, but it's slowing down. The gravitational force is the force of the